Hello friends, I'm Pavitra. Welcome to another session of Leibnitz Rule. So in the last session, I told you about the Leibniz Rule. So Leibniz Rule is for finding the nth derivative of product of two functions. This is the formula for Leibniz Rule and some basic formulas. Okay, we'll solve some more problems in the Leibniz Rule. So the first problem I have taken here is if tan y is equal to x, then we need to prove the first result 1 plus x square y2 plus 2x y1 is equal to 0, and we have to apply the Leibniz rule and find the second result. This one. Okay. So consider the given function. Given tan y is equal to x. So you write it as a y is equal to. So y is equal to tan inverse x. So differentiating with respect to x, you will get y1 is equal to differentiation of tan inverse is 1 divided by 1 plus x square, right? So cross multiply, so that is 1 plus x square into y1 is equal to 1, right? So now differentiate one more time. So 1 plus x square as it is, differentiation of y1 is y2 plus y1 as it is, differentiation of 1 plus x square is 2x. So that is equal to differentiation of 1 is 0. So therefore it is 1 plus x square into y2 plus 2x into y1 is equal to 0. So this is the first result. So now apply the Leibniz rule, find the nth derivative of this. So to find the nth derivative, apply the Leibniz rule. So that is 1 plus first function 1 plus x square as it is. Nth derivative of y2 is yn plus 2 plus nc1 is n. So differentiation of 1 plus x square is 2x. So n minus 1th derivative of y2 is yn plus 1 plus nc2, that is n into n minus 1 divided by 2 factorial into differentiation of 2x is 2, then n minus 2th derivative of y2 is yn. Next differentiation of 2 becomes 0, so that is the first nth order derivative. Next for 2x into y1, so 2x as it is, nth derivative of y1 is yn plus 1 plus nc1 is n, differentiation of 2x is 2, then n minus 1th derivative of y1 is yn, so that is equal to 0. So now simplify this term, so that is 1 plus x square into yn plus 2 plus, so take the common here. So here this is yn plus 1th term and this is yn plus 1th term. Here 2x is common. So that is yn plus 1 also common. So in the first term n plus 1 into 2x into yn plus 1, right? Then plus, now in the yn term, so this is yn term and this is yn term. So here 2 get cancelled. N is there, right? So n is common, then yn is common. So in the first term n minus 1 remains plus 2 remains, n into yn is equal to 0. So right. So that is 1 plus x square into yn plus 2 plus 2 into n plus 1 x yn plus 1 plus n minus 1 plus 2 is n plus 1, n into n plus 1 yn is equal to 0. So this is the result. 2n plus 1 x into yn, n into n plus 1 yn. Okay. So this is the first problem. So for the second problem, I have considered y raised to 1 by m plus y raised to minus 1 by m is equal to 2x. Then we need to show the result. So first what we will do, you have to simplify this function. Okay. So given y raised to 1 by m plus y raised to minus 1 by m is equal to 2x, right? So this is, we can write it as y raised to 1 by m plus y raised to minus 1 by m, I can write it as 1 divided by y raised to 1 by m is equal to 2x. So now what I will do, put t is equal to y raised to 1 by m. So we will get t plus 1 divided by t is equal to 2x. So simplify this one. So take the LCM, you will get t square plus 1. So cross multiply, you will get 2x into t, right? So the quadratic equation becomes t square minus 2x into t plus 1 is equal to 0. So now you have to, that this is the quadratic equation in t. The solution for this. So that is t is equal to minus b plus or minus root of b square minus 4ac divided by 2a, right? So that is minus b here is minus 2x. So minus b minus into minus 2x plus or minus root of b square minus 2x whole square is 4x square minus 4 into a is 1 and c is 1. 4ac is minus 4 divided by 2a. 2 into a is 1 here. So now that is equal to t is equal to minus into minus plus. So that is 2x plus 4. You can take common, root of 4 is plus or minus, that is root of 4 is 2, root of x square minus 1 divided by 2. So in all the term 2 we can get cancelled. So therefore t is equal to x plus or minus root of x square minus 1. Okay, so this is the root for t. So either it may be a plus or minus. In both the case we should consider it here. Okay, so first I will consider t is equal to x plus root of 1 minus x square. So consider the case 1. So that is t is equal to x plus root of x square minus 1. Okay, so what is t? So I have substituted for t is y raised to 1 by m. So t is y raised to 1 by m. So therefore y raised to 1 by m is equal to x plus root of x square minus 1. We can write y is equal to, raising the power m, you will get y is equal to x plus root of x square minus 1 raised to m. So now instead of differentiating directly, take log on both sides. So I will get log y is equal to, by the property of log a raised to x is x into log a. So that is m into log x plus root of x square minus 1, right? So now differentiating with respect to x, what is the differentiation of log y? With respect to x, so that is 1 by y into dy by dx, that is y1 is equal to, m is constant, differentiation of log, it is 1 divided by x plus root of x square minus 1 into differentiation of x plus root. So that is 1 plus 1 divided by 2 root x square minus 1. So that is root x. Differentiation is 1 divided by 2 root x. So 1 divided by 2 root this into differentiation of x square minus 1 is 2x. Right. So now that is equal to, take the LCM. Here 2 get cancelled. Take the LCM. So that is 1 divided by x plus root of x square minus 1 into root of x square minus 1 plus x divided by root of x square minus 1. So x plus root of x square minus 1, x plus root of x square minus 1 get cancelled. So that is equal to divided by root of x square minus 1. Right. So you can take y also that side. So therefore y1 is equal to, you can write, so that is y1 is equal to my divided by root of x square minus 1. So this you take it as a first equation. Okay. So now case 2, if I consider t is equal to x minus root of x square minus 1. So write for the case 2. So that is case 2. If t is equal to x minus root of x square minus 1. So t is y raised to 1 by m is equal to x minus root of x square minus 1. Right. So raising the power, same line, y is equal to x minus root of x square minus 1 raised to m. Now again take log on both sides. Log y is equal to m into log x minus root of x square minus 1. Okay. So now differentiating with respect to x. So you will get 1 by y into y1 is equal to m is constant, 1 divided by x minus root of x square minus 1 into x minus root of x square minus 1 differentiation is 1 minus 1 divided by 2 root x square minus 1 into 2x. Right. So this 2 get cancelled. Right. So now take the LCM and simplify. So that is 1 by y into y1 is equal to m divided by x minus root of x square minus 1. So take the LCM, root of x square minus 1 is common. Root of x square minus 1 minus x divided by, so root of x square minus 1. Right. So now this is negative and this alternative sign is there. If I take the negative sign common, so we can cancel it. So that is one more step I will write it here. So that is minus m into root of x square minus 1. So this is negative plus x divided by x minus root of x square minus 1 into root of x square minus 1. So this term and this term get cancelled, right? So that is y1 is equal to you will get minus my divided by root of x square minus 1, right? So this is equation number 2. So here y1 is negative. In the equation 1, y1 becomes positive, right? So to make it as a positive, what I will do, both the equation I will squaring on both sides. So squaring, you will get y1 square. So you will get y1 square is equal to m square into y square, right, divided by x square minus 1. So this equation squaring and equating. So you'll get this equation. So therefore y1 square into x square minus 1, right, minus m square y square is equal to 0. So this is the equation. Now differentiating another time, means differentiating one more time, you will get x square minus 1 as it is. What is the differentiation of y1 square? So that is 2 into y1, right, 2 into y1 into y2, correct, plus y1 square as it is. What is the differentiation of x square minus 1? So that is 2x, right, minus m square into differentiation of y square is 2y into y1 is equal to 0, right. So now in all the term y1 is common, we can cancel it, and 2 also we can cancel. So you will get x square minus 1 into y2, right, plus x into y1 minus m square y is equal to 0. So this is the equation, correct. So y1 and 2 also I have cancelled. So now what I will do, apply the Leibnitz rule and simplify. So what you will get, x square minus 1 as it is. Nth derivative of y2 is yn plus 2, right, yn plus 2 plus nc1 is n, x square minus 1 differentiation is 2x, n minus 1th derivative of y2 is yn plus 1 plus nc2, that is n into n minus 1 divided by 2 factorial is 2, differentiation of 2x is 2, n minus 2th derivative of y2 is yn. Similarly second term plus x as it is, nth derivative of y1 is yn plus 1, right, plus nc1, n minus 1th derivative of y1 is yn, correct, then minus m square into nth derivative of y is yn is equal to 0. So here 2 get cancelled, right. Now simplify x square, so we'll get x square minus 1 y raised to n plus 2, right, plus yn plus 1th term. So this is yn plus 1th term, this is yn plus 1th term, and this is yn plus 1th term. What is common? X into yn plus 1 is common. So you'll get 2n plus second term remains 1, x into yn plus 1, correct. Then plus yn term. So this is yn term, and yn term. So sum, okay, plus multiply. So n square minus n, so plus n second term, then the third term is minus m square into yn is equal to 0. Plus n minus n get cancelled. In the next step you can write n square minus m square into yn. Okay. So this is the result. Let's check the result. So x square minus 1 yn plus 2 plus 2n plus 1 x into yn plus 1 n square minus m square yn. So this problem is very important for the examination. Okay, thank you for watching. Please like, share, comment and subscribe to my channel. Thank you so much.